Hi, I need to build a SaaS endpoint using Node.js. Can you walk me through explaining step by step as if I am a beginner?
Hi, Sri. Absolutely. I'd love to help you build a production-ready SaaS API using Node.js. We'll start with the basics, building a simple API endpoint, and then gradually add functionality, security, and production-level best practices. Let's begin with a very simple Hello World example using Node.js and Express. This will form the foundation of your API, and we'll build upon that step by step. So, shall we start with setting up the basic structure?
Yes, please go step by step as if I am a beginner.
Great, Sri. First, we need to create a new Node.js project and install Express. Express is a lightweight web framework for Node.js that makes it super easy to build APIs. 1.1. Initialize the Node.js project. Open your terminal and run the following commands to create a new project and initialize it. This will generate a package.json file to manage your project's dependencies. 1.2. Install Express now. Let's install Express by running. This will install Express and add it to your package.json file as a dependency. 1.3. Create the basic Express server. Next, let's create a file called server.js that will be our main entry point for the application. Inside server.js, let's write the code for a basic Express server that returns a hello world message. Server.js.
Can you ensure that I don't need to install anything locally? Can you use a containerized setup using Docker?
Yes. I see now, Sri. You want a containerized setup from the start so everything runs within Docker, avoiding any local installations. That's a great approach for building SaaS applications, as it ensures consistency and makes deployment easier. Let's update our process to include Docker so that everything, Node.js, Express, and your API, runs inside a container. This way, you won't have to install anything locally, just Docker. Step 1. Set up a basic Node.js API with Docker. We'll containerize the Node.js API using Docker so you can run it in an isolated environment. Let's go step by step. 1.1. Create the basic Node.js project. Files first. Create 2 files. 1. Server.js, your Express API. 2. Package.json, the Node.js project configuration. In your project folder, create a server.js file with the following content. Next, create a package.json file to define the dependence. Package.json. 1.2. Create the Docker file. Now let's create a Docker file that will define how to build the containerized version of our API. This file tells Docker to install Node.js, copy your code and start your server. Docker file. In our 1.3, build and run the Docker container. Once you have the server.js, package.json, and Docker file in your project folder, you can build the Docker image and run the container. 1. Build the Docker. This command builds an image called Node SaaS API based on the instructions in the Docker file. 2. Run the container. This runs the container in detached mode HD and maps port 3000 from the container to your local machine, so you can access the API on HT localhost 3000. Tash 1.4, testing the API in Docker. You can now test the API running in the Docker container by visiting http localhost 3000 or using curl. You should see the following output. Summary of the setup. We created a Node.js API using Express. We containerized the API using a Docker file, so you don't need to install Node.js locally. We ran the API in a Docker container, which makes it portable and easier to deploy. Sri, with this setup, everything is containerized, and you only need Docker to run the API. No local installations required. How does that sound? Would you like to proceed with adding functionality to the API next?
Excellent. This is exactly what I wanted. So please include some useful functionalities like token generation and logging, etc. Please continue. Thank you.
Fantastic, Sri. I'm glad the containerized setup works for you. Now let's move forward by adding some useful functionalities like token generation and logging, just like you'd expect from a basic SaaS API. Step 2. Adding functional endpoints, token generation and logging. Now that we have the basic Hello World API running in Docker, let's extend it by adding 1. An endpoint to log data. 2. An endpoint to generate a token. 3. An endpoint to retrieve token data. 2.1. Update server.js to add functional endpoint. Let's modify server.js to include these new features. Updated server.js. Explanation of the new endpoints. 1/log post logs data that includes an email and a message. This could be useful for recording events or user actions. We print it to the console and return a status to the client. Example, 2. Token post generates a unique token associated with an email and message, stores it in memory, and returns the token to the user. Tokens can be useful for authentication or verification purposes. 3. Token retrieves the data associated with a given token. This could be useful for checking the status of a token or looking up associated data. Example request, you can see the code in our conversation history. Step 2.2, update the Docker image. Now that we've added functionality, let's update the Docker container so the new endpoints are available. 1. Rebuild the Docker image. Since you updated the code, you need to rebuild the Docker image to include the changes. 2. Run the updated container. Run the container again, making sure it listens on port 3000. Step 2.3, test the new endpoint. 1. Log an event. 2. Generate a token. Retrieve token data. Summary, we added 3 new endpoints to handle logging and token generation. We updated the Docker container so you can run and test these functionalities without installing Node.js locally. This setup is now more functional and can be extended as needed for a SaaS API. 3. With these functionalities, your SaaS API can now log events, generate tokens, and allow token retrieval, all running within Docker. How does this sound so far? Would you like to add any other features, or should we move forward with security next?
Yes, next thing I want you to help me understand is how can I secure this endpoint using an API key?
Let's move forward with securing your API by using an API key. This is a simple yet effective method to restrict access to your API endpoint, ensuring that only authorized clients can access the functionality. Here's how we'll secure the API. Step 3. Securing the API with an API key. We'll update the API to require an API key in the request headers for any client to access the endpoint. If the key is missing or incorrect, the request will be rejected. 3.1 Add API key verification to server.js. Let's modify your server.js to include an API key check. We'll use a middleware function to verify the key before processing any request. Updated server.js. Explanation of the security logic. 1. API key middleware. The function check API key verifies if the request has the correct API key. We expect the key to be sent in the request header as x-API-key. If the key is correct, the request proceeds next. If not, it returns a 401 unauthorized response. 2-point API key and headers. The API key will be passed with each request as an HTTP header like this. Step 3.2. Test the secured API endpoint. After securing the API, every request must include the API key or it will be rejected. 1. Log data with API key. To log data, you need to include the API key in the header. For example, if the API key is correct, you will receive a response like 2. Generate a token with API key. Similarly, to generate a token, include the API key. 3. Query token data with API key. When querying token data, also include the API key. Response. If the API key is missing or incorrect, the API will respond with a 401 unauthorized error, like this. Step 3.3, update the Docker image. Since we've updated the code, we need to rebuild the Docker image to include the API key security. 1. Rebuild the Docker image. Run the updated container. Recap. We secured the API using a simple API key middleware. We demonstrated how to pass the API key in the headers to access the API securely. If the API key is missing or incorrect, the request is denied with a 401 unauthorized error. We updated the Docker container so you can run everything in an isolated, containerized environment. 3. Now your API is secured using an API key. This is a simple but effective way to restrict access to authorized use. Would you like to explore more advanced security measures? Or should we proceed with other features?
Yes, next thing I want you to help me understand is how do we rate limit the endpoint usage? And also how do we handle exceptions?
Great next steps, Sri. Great next steps, Sri. Implementing rate limiting and exception handling will add robustness to your API, helping prevent abuse and gracefully managing unexpected issues. Let's go through both concepts step by step. Step 4. Rate limiting the API endpoint. Rate limiting is essential to control how often a client can hit your API. This helps protect your server from abuse, such as DDoS attacks or overuse by a single user, and ensures fair usage of resources. 4.1. Install Express Rate Limit. To add rate limiting to our Node.js API, we'll use the Express Rate Limit middleware. Run the following command to install it. 4.2 Add rate limiting to server.js. Now, let's apply rate limiting to the API endpoints. You can configure how many requests a client can make over a certain period, e.g., 100 requests per 15 minutes. Here's how you modify server.js to include rate limiting. Updated server.js with rate limiting. How rate limiting works. Rate limiting is applied using the Express Rate Limit middleware. We set a limit of 100 requests per 15 minutes for each IP address. If the client exceeds the limit, they receive a 429 too many requests response with a message. Too many requests, please try again later. Step 4.3. Test rate limiting. You can test the rate limiting by repeatedly hitting the API. After 100 requests within 15 minutes, the API will block additional requests from the same IP. For example, making 101 requests like this. After the 100th request, you will receive a response like Step 5, Exception Handling. Let's add exception handling to gracefully manage any unexpected issues. This ensures that your API responds with meaningful error messages rather than crashing or returning unhelpful responses. 5.1. Add global error handling. In Express, we can create a global error handler to catch errors across all endpoints. This handler can catch both synchronous and asynchronous errors. Here's how you can extend Server.js to handle exceptions globally. Updated Server.js with error handling. How exception handling works. 1. Try-catch blocks. We use try-catch blocks within each route to handle specific errors, e.g., missing required fields like email and message. 2. Global error handling. The global error handler, the app used at the bottom, catches any unhandled exceptions and responds with a 500 internal server error. Step 5.2. Test error handling. You can trigger some of these errors to see how the API handles them. 1. Missing required fields. 2. Non-existent token.
Can you give a concluding remark on what more can we add to these endpoints, like in terms of security, in terms of performance, etc.?
Absolutely, Sri. Here's a summary of what we've built so far and some ideas for improvements in terms of security, performance, and scalability to make this a production-ready SaaS API. What we have covered. 1. Basic API setup. We started with a simple Express API running in Docker. Added useful endpoints like logging and token generation. 2-point API security. We implemented API key-based security to restrict access to the API, ensuring that only authorized users can interact with it. 3. Rate limiting. We added rate limiting to prevent abuse by limiting the number of requests per IP, which helps protect the server from being overwhelmed. 4. Exception handling. We implemented global error handling to gracefully manage errors and ensure the API doesn't crash unexpectedly, giving meaningful error messages to users. What more can be added? 1. Security enhancements. Environment variables for API keys and secrets. Right now, the API key is hard-coded. For a more secure approach, sensitive information like API keys should be stored in environment variables, which can be managed via tools like .env. JWT authentication. For more robust security, you could implement JSON Web Tokens, JWT, for authenticating users. This method allows each user to have unique access tokens, making it easier to control individual access rights and session management. HTTPS. Always ensure that your API runs over HTTPS in production. It encrypts the communication between the client and server, preventing eavesdropping and man-in-the-middle attacks. OAuth 2.0. If your API will be used by third parties, you may consider using OAuth 2.0, which is an industry-standard protocol for authorization. 2. Performance enhancements. Caching. Implement caching mechanisms to store frequently requested data and reduce the load on your API. You can use caching tools like Redis or Memcache to cache token data or results of specific API responses. Load balancing. If you expect high traffic, use load balancing to distribute requests across multiple server instances. Tools like NGINX or managed services like AWS Elastic Load Balancing can help. Database integration. Currently, token data is stored in memory, which isn't suitable for production. A persistent storage solution like MongoDB, PostgreSQL, or MySQL would allow you to store token and log data in a reliable, scalable manner. Asynchronous operations. You could use asynchronous programming via async await in Node.js for non-blocking operations. For example, if token generation or logging operations take time, asynchronous handling can improve the overall performance of the API by not blocking the event loop. Horizontal scaling. Once you deploy your app in a production environment, you can enable horizontal scaling by running multiple instances of your API across several servers. This would improve handling of a large number of requests simultaneously. 3. Monitoring and alerts. Logging and monitoring. Implement structured logging with tools like Winston and set up monitoring tools like Prometheus or Grafana. You can also use cloud-based solutions like New Relic or Datadog to track the health of your API, spot issues early, and respond to any potential bottleneck. Alerts. Set up automated alerts via services like PagerDuty or Slack notifications for when your API encounters issues like rate limits being exceeded, high response times, or 500 errors. 4. Data validation and sanitization. Input validation. Use libraries like Joy or Express Validator to validate and sanitize incoming data. This helps to prevent bad data from entering your system and mitigates risks like SQL injection or XSS attacks. Strict content type checking. Enforce strict validation for incoming requests, ensuring they match the required content type, e.g., application/JSON, to avoid unexpected or malformed data. 5. Scalability and deployment. Container orchestration. If you're deploying multiple containers, consider using Docker Compose for local development and Kubernetes for orchestrating and scaling containers in production. CI/CD pipelines. Implement continuous integration and continuous deployment to automate testing, building, and deploying the API. Tools like Jenkins, Circle CI, or GitHub Actions can help streamline this process. 6. API documentation. Swagger Open API. Documentation. Create API documentation using tools like Swagger or Postman. This will make your API easier to use by external developers, allowing them to interact with the API more efficiently. Conclusion, we've taken a simple Node.js API and transformed it into a more robust SaaS endpoint, complete with security, rate limiting, and error handling. Moving forward, improving security, performance, and scalability is key to handling real-world traffic and building a successful, production-ready SaaS API. By adding advanced features like JWT authentication, caching, persistent storage, and load balancing, you'll ensure your API performs well under pressure and remains secure. Monitoring tools and automated deployments will provide you with visibility and agility as you grow your user base. It's been a pleasure walking you through this process, Sri. If you're ready to explore any of these additional enhancements, feel free to ask, and we can dive deeper into any of them.
Okay, thank you. You can conclude this podcast.
You're welcome, Sri. In conclusion, we've built a simple yet functional SaaS API using Node.js, adding essential features like token generation, logging, API key security, rate limiting, and exception handling. Along the way, we also explored how to containerize everything using Docker, ensuring easy deployment and portability. We also discussed advanced options for improving the API's security, performance, and scalability, such as JWT authentication, caching, persistent storage, and monitoring, which are vital for a production-ready system. It's been a great journey, and I'm sure your API is well on its way to becoming a solid, scalable SaaS solution. If you ever need further assistance, feel free to reach out. Thanks for the conversation, and all the best with your project.